Good morning. Okay, let's continue. So this is our third lecture on survey research, and you must have noticed that there's more and more math involved in our class. So don't be scared. I hope you have sort of tried to work out the homework assignments, or at least have taken a look. Um, you should note that the level of math that is involved in this class is very minimal, right? You're not required to solve differentials. You're not supposed to or expected to know anything about limits or more advanced mathematics. What you need to know is how to do simple divisions and of course multiplications, additions, and subtraction. But more importantly is the reason behind um, all the different calculations, right? So statistics, in a sense, is more about thinking, right? Why you do this, why you add this number to that number, and why you subtract or divide the number by another number, right? So understanding the reasoning at least at this level, is more important than your mathematical skills, which I'm sure all of us are equally equipped. Okay? Right, so don't be discouraged if you um, were a little confused or overwhelmed, even, right, at the start. I promise you that as long as you are persistent, as long as you have the courage, right, or determination, you will do just fine. Okay, enough of chicken soup, and let's continue. Okay, so last time, I should say, right, we're talking about this particular way of sampling that we call stratified sampling. The reason that we, you know, um, need to talk about stratified sampling is because there will be this problem of over and under representation, right? So imagine you have a group that consists of men and women, um, and because of the process of sampling, you might overrepresent men in your sample, right, compared to the number of men or proportion of men in the population, and consequently, you might underrepresent women in your sample compared to the actual proportion in the of women in the population. So the idea is that, well, if proportion is kind of important, right, in the sampling procedure, because if you overrepresent a segment in the population, your result might be biased. That actually is a pretty important point. So let's spend a few minutes deciding why that's the matter. Why that's important. Okay, so how can I do this? Let me actually exit. And I would, okay, start with a blank slide here. So let's, figure out or, understand why, underrepresentation or overrepresentation might bias your result. Okay? All right, so let's see. Imagine we have a population, right? Whatever it is, it can be UHM students, it can be Honolulu citizens, doesn't matter. And you ask them about their views on, well, let's use our favorite example, legalizing, right? Um, Drug use, recreational drugs, right? So let's say we have men, right, in our population, um, and we also have women, right, in our population. In the spirit of, conforming to biological laws, we will have more men than women, okay, for reasons that you will understand by taking my evolution class. Okay, so, and it is a typical finding that if you ask men and women how much you support legalizing recreational drug use, men in general, on average, will be very okay with that, if not, favoring legalizing recreational drug use. So let's say on a 7 point scale, right, with one being against, seven being for or favoring, right, man would say, well, sure, I'm pretty, uh, I like the idea of, legalizing marijuana use. So there might be one that says, well, I don't know. And most of them, like, hypothetically, right, will say, sure. This guy said, yeah, why not? Let's totally legalize it. Legalize it. Comparatively, women, for reasons that we might have a chance to discuss or might not, they are typically more conservative, right? On average, there will be conservative guys and liberal girls, but in general, on average, women as a group are more conservative than men. So, on this scale, they would say, I would score a 4, borderline, but this woman says, no, I'm not liking this idea, and these two ladies are totally against, very against. So 2 and 1. Okay, so if we're able to survey every single individual in this population, right, by tallying their numbers, we will be able to get a group average, right? So we have 5 plus 5 plus 6 plus 4 plus 7, right? Those are men's scores, and then we have women's scores, right? So we have 3, we have 4, we have 2, we have 1, and then we divide the sum by 1, 2, 3, 4, 5, 9 people in total, right? So whatever number we got here will be the group average, right? So this is 10, 10, 27, 30, 36, 37. 37 divided by 9 will be 4 point something, right? Because 4 times 9, that will be 36, right? And then we have 37, so it will be 4 point something, 4.01, okay? All right, so, that's actually on a 7 point scale right at the middle, because the conservativeness of women and the liberalness of men, they cancel each other out. So the group average is actually a 4. Okay? So that is provided that we can survey every single individual in the population. But we said in the previous class, that it is actually very difficult in real life to survey every single individual in the population. So the solution is, well, because we don't have the time or energy or money to include everybody, from the population in our study, we will survey a subset, right, of people from the population we call sample. Okay? So we said that our result will be good and can be generalized if our sample resembles our population. In this case, right, if our sample resembles, our population, that will be, we have more guys, but only slightly more guys than women, right, in our sample. So this is a subset of our population. So if we can do this, that will be fine, right? Um, because this sample we say is representative of this population because we can easily calculate the ratio, the gender ratio here. So we have 5 men versus 4 women, right? So that's about 1.25 versus 1, right? So for every 1 woman, we have 1.25 men. So here, what is our, gender ratio? We have 3 versus 2. That is, 1.5 to 1. That's already a little, different because, well, that's sort of inevitable because the number is very small here, right? So, if we increase the number in population sample to be larger, in hundreds or in thousands, the difference here, 1.5 versus 1 and 1.25 versus 1, will be, you know, can be safely ignored. Okay, so let's, assume, well, so let's take these two ratios as, roughly quite similar, right? Because, it's about half, half of the guys, half of the women, okay? So let's say we randomly select from these 5 men, um, these three, right? Those who score 6, those who score 7, and those who scored 6. At the same time, we select randomly, out of the 4 women, 2 of them, one is 2, and the other is 3. Okay, so we can similarly calculate the sample average, right? So this is the population average. Now we can similarly calculate the sample average. So it will be 4 plus 7 plus 6 plus 2 plus 1, and we divide everything by 5 because now there are 5 people here, right? So what is our result here? So this is 10, this is 10, 20. 20 divided by 5, 4. Fantastic. That's very close, actually, to our population average, right? So in this case, we can safely say that, because our sample is very representative of our population, at least in terms of gender ratio or composition, our result can be generalized to the population, right? So in fact, we're correct because 4 is very, very close to 4.01. Okay? So now let's see what will happen if we under or overrepresent a particular sex or gender here. You can immediately see actually, right, without me going through the reasoning process. But, nevertheless, let's do that. So let's say you overrepresent men here. By that we mean you have way more men than women in your sample compared to the gender ratio in our population. So let's, stick to the idea that in a sample, let's have 5 people. So here, within 5 people, we have 3 men, 2 women. But let's see what will happen if we have all 5 of them as guys. You would immediately see that this creates a problem because, if all of them are the guys from the population, 5, 5, 4, 7, and once we calculate the sample average, 5, 5, 6, 4, 7 divided by 5, what is the average? 10, 10, 27 divided by 5, that will be 5.4. Okay? Do you see the difference here? That's a point, over a point above the midpoint in the direction of being liberal on this issue. So, if we rely on our sample here, if we rely on the sample average here, and if we generalize our sample average to the population, will be led to conclude that you know these people, whatever these people are, they're actually favoring the decision to legalizing marijuana use, which we know is actually not the case because if we look at the population, the mean is actually moderate, right? Favoring neither direction. But if we overrepresent men here, we might be under the impression that these men, these people, right? Because we're making generalizations, will be under the impression that these people actually will be in favor of legalizing marijuana use. And you can similarly decide what will be the problem if we overrepresent women. Say we have all the women, all four of them in a sample, right? Plus one man, right? Because we want a sample of five. And you can similarly consider or calculate the average here, right? By giving them numbers. So this is 2, 3, 1, 4, right? According to our values here. And you can just give this guy any value, one of the five. You can give him a 7, right? Doesn't matter. So, 2, 3, 1, 4, we can calculate it, right? 2, 3, 1, 4 plus 7. What is it? Divided by 5. So this will be 10. This will be 5. 17, right? 17 divided by 5. What is it? 3.4. That is in the direction of being conservative on this issue. So if you overrepresent women in your sample, you will be led to conclude that these people, in general, on average, will be against legalizing marijuana use, which is also inconsistent with our knowledge about the population position, right, on this issue. So that's why over and underrepresenting any segment in our sample compared to the population will lead to biasing results, right? Will lead us to make conclusions that's actually not true. So that's why, you know, fairly representing each segment in the population, you know, in the sample relative to the population, or as accurately as possible, right, is a very, very important issue in conducting survey research. Okay? So that's why we spend this much time on this particular method that we called stratified sampling. And to stratify sample a certain, population, the idea actually is very simple, right? So we know that the procedure of it based on our previous lecture. So let's say this is our population. Okay? So this is our population. And then you, based on your knowledge, prior knowledge, based on theory, whatever, right? And based on the goal of this survey, of course, you reason, well, now our goal is to find out people's attitudes toward, let's say, gun control, right? And you know that Republicans and Democrats, they will have vastly different ideas and views on this particular issue. In other words, fairly representing, right, the number of Democrats and Republicans in a sample relative to the population is key to the success of this particular survey, right? So what you would do is, of course, you will look at, go online. Well, I'm sure there will be, sources for this information. That is roughly how many Democrats and Republicans or registered Democrats and Republicans in this country. So you will say, okay, so if party affiliation is that important, then I will stratify this population or create a stratified sample by considering the appropriate percentage of Democrats and Republicans, or Republicans versus Democrats. Okay? Well, if you want to be even more precise, you will also consider how many, right, the correct percentage of independents in this country, right? So by knowing their relative percentage or proportion in the populations, let's say Republicans versus Democrats is like 1.5 versus 1. I don't know, I'm making this up. 4 versus 1, right? By knowing this proportion, now that gives you sort of a guidance in terms of how many Democrats, independents, Republicans you should include in your sample, right? So the first step is you create different strata, right? The second step is by knowing the population percentages, and of course your sample size, your target sample size, right? How many people you would like to include in your sample. You'll be able to find out exactly how many Democrats, how many independents, how many Republicans you should recruit in your sample. Okay, so that's sort of the procedure of stratified sampling. So, oops. So tomorrow, sorry, not tomorrow, yesterday, I'm sorry, I was drunk. Well, just kidding, I'm tired. Well, yesterday, we talked about this particular question or problem, right? So, imagine we have a population that has, for every one independent, we have 1.5 Democrats and 2.5 Republicans. Okay, so this is the population percentages for these three strata. And now we want to recruit 100 people that include the fair amount of Republicans, Democrats, and independents. Okay, so the question is how many Republicans, Democrats, and independents you should include in a sample so that their number will add up to 100 and their percentages should be conforming to this population proportion. Okay, and we said that, well, the solution is very easy. How do I do this? Oh, is this a fancier drawing tool? Maybe it is. I don't know. Um, let's try. Okay. Oh, it is kind of fancy. All right. So the idea is this, right? So let's say we want to figure out how many Republicans we should include. So the first step of doing that is to find out, well, what should be the correct proportion of Republicans relative to the entire population, which consists of Republicans, Democrats, and independents. So the first step is to add up. Okay, I don't like this. I'm sorry. So I will stick to the original tool here. Okay, so the first step is to find out, okay, so what should be the proportion of Republicans relative to the entire population? And because the entire population consists of three segments, right? So it will be Republicans, Democrats, and independents. And we want to find out how many Republicans. So that is, we add this up, it will be 5, right? So that is, for every 5 people in the population, there will be 2.5 Republicans. Now, if we want 100 people, then how many Republicans do we want? Well, you time the target sample size, right, with the correct proportion of Republicans in the population, and that will give you 50 people. All right. We repeat the procedure for Democrats and independents. We'll get 30 Democrats and 20 independents. Right. The steps of getting these numbers I showed in the clips of yesterday. So I'll be fast today here, right, with this recap. And then, these three numbers, of course, add up to 100. And if you work out the proportions, right, you divide 20 by 20, that will be 1. 30, you divide 30 by 20, that will give you 1.5. If you divide 50 by 20, that will give you 2.5. See? So, not only do these three numbers add up to 100, their relative proportion in a sample conforms to the relative proportion in the population. So there we go. Okay. All right. So we ended yesterday's class on this slide. That is, you know, we can of course stratify a sample based on one single factor, based on gender or based on their party affiliation. But at the same time, we can stratify a sample based on multiple features. So imagine we want to stratify COMG majors based on their gender, men and women, and their status as domestic students versus international students. My question for you yesterday is how many strata we should create. Okay, so I hope you have devoted some thoughts to it, but if you haven't, that's also okay. We can do this together. So it's relatively easy if we only consider what if we only stratify COMG majors based on one single factor, let's say gender. And you can immediately say that, based on convention, right, we can and we should create two strata. With men, we have women. Okay? Following the same reasoning, here is even easier, right? Because I have already told you that there are two types of students, domestic, international. So if we simply stratify COMG majors based on this dimension, we'll similarly have two strata, domestic, international. But now we're combining these two dimensions. We're stratifying COMG majors based on their gender and based on their student status at the same time. So this creates sort of a problem that is, well, then how many strata should we include? Should we create? Okay? Well, the answer is 4. But I want to emphasize that, how you get this answer is important, because I can sort of imagine and hope I'm wrong that you get this number by saying or reasoning, I have two strata here under gender and I have two strata here under domestic, international, so 2 plus 2, that will give me 4. Okay, so this is a typical example of you have the correct answer based on wrong reasoning, right? So the way that we get 4 is not by addition, but rather by multiplication. 2 times 2 equals to 4. And why we're doing multiplication here? Well, here's the reasoning, okay? So whenever we have multiple dimensions based on which to stratify a population, we always do it by layers, right? Here's what we mean. We have population here. That's all COMG students or COMG majors. The first stratification you would do is to base this stratification on gender. Doesn't matter if you start with gender or their status, right? Let's say we start with gender. So we know this is kind of easy because we only have 2 gender groups by convention. But then the next question to consider is, of course, what would be the second layer of stratification? Because you can consider, well, there will be male domestic students and there will be male international students. Similarly, we have women or domestic female students and international female students. See, this is our first layer of stratification, and this is our second layer of stratification. So why is multiplication? Because for each strata in the first layer, it has two further, well, for each stratum at the first layer, it has 2 strata under it, right? So here we have 2, and then we have another 2, right? So that's 2 by 2, right? We have 2 such layers, right? This is one layer, and we have 2 layers of this kind. So it's 2 by 2, right? And just to verify that multiplication rather than summation makes sense, let's make this example even more complicated. So domestic, international, and what else can we think of? Native. Okay. So let's designate that domestic means they're from U.S. mainland. Okay. Native means they're from this island. Okay. International, of course, from other countries. So now my question is how many strata do we create? Okay, I'll give you several seconds to consider while I take a sip of water. Um, what should we answer? Okay, so if you have paid attention to this lecture all along, you should know the answer will be 2 times 3, 6. Okay? But okay, you're saying, well, I only know this because I know that Andrew said you should do um, multiplication. Okay? Because if you do summation, it will be 2 plus 3. That will give you 5, which of course is not 6. So this is wrong, and this is correct. But how do we make sense of it? Right? So let's do this, visualize this again. So we have COM-G majors. And then we start as well by stratifying based on gender with men, women by convention. Now you should know that under each stratum in the first layer, there will be 3 groups: domestic, international, and native. And we repeat this further stratification a second time under women, right? Domestic, international, native. So we have 1 3, 2 3s. So 2 3s, that gives us 6. Well, you say, well, what if we start the stratification by their status? That will give you the same answer, right? So we stratify by status, so we'll create 3 strata at the first step. So domestic, international, native. Under each stratum in the first layer, we have male domestic, female domestic, male domestic, female domestic, and repeat this for the third time. Male domestic, male native, male, female native. So we have 1 2, 2 2s, and 3 2s. So 3 2s, that's 6. There we go. Okay? So this is how we decide or work out our plan of stratification. Okay? So I'm going to erase all this. But, it's a video clip, so you can always rewind and, sort of make sense of the procedure here. So my next question is how do we visualize, this stratification plan, which we have already done, okay, on the trees and decisions, branches, right? So, okay, so we've done that. Now the question is, okay, let's decide that or assume that, within all COM-G majors, right? So this will be our population. So the population gender proposition will be men versus women is 2 versus 1. And in this population, we have, for every 1 international student, we have 4 domestic students. So let's say Angie would like to sample 300 COM-G students. a question for Angie and for all of you will be, how many male domestic students should Angie recruit? Okay? So you should very easily be able to work out how many men should Angie recruit if, we only have this one dimension, right? That will be very super easy, right? Because we're all very smart, intelligent, and we know what to do. So, first of all, let's work out how many men, you know, there should be, in the population. So for every two men, we'll have three people, or for every three people, we'll have two men. So two plus one, right? That will give us the population, because in this population there are only men and women. So it's two plus one that gives us the population. So every three men there will be two. Every three people there will be two men. So now we want 300 of them. That will give us 200 men. So we should include 200 men, all right? But it's also very easy if we only have this stratification, right? So now let's ignore men, women, and how do we solve this problem? How many, let's say, domestic students should we have? So very easy, right? So we can first work out, for every five people, so 4 plus 1 is 5, right? So for every five people, there will be 4 domestic students. And then we times that with 300. So this 5, we should have 240. I hope I'm right. I think I'm right. Okay, so if we only stratify by gender, Angie should have 200 men. If we only stratify by status, Angie should recruit 240 domestic students. But now the question for Angie is, how many male domestic students? That is, how many students that are men and domestic at the same time, right? So obviously we cannot simply add these two numbers together, because if we add them together, that will give us what, 440 people, and that's larger than our sample size, so that can't be the case. And similarly, we can just do a simple subtraction, because if we subtract 200 from 240, that will give us 40, and that doesn't look right either. Okay, so here, just as we work out the plan of justification by layers, via a step-by-step procedure, we should also work out the number step by step. Okay, so here's the correct procedure to do this. Okay, so let's start by stratifying this population based on gender, and we want the number of men that Angie should include. So that's easy. So 2 over 3, right? For every 3 people, 2 plus 1, there will be 2 men. So, and we want 300 people, so that will give us 200 people. Okay. Now, this is the critical second step. This step suggests, or the reasoning behind this step is, for men and women, the proportion between domestic and international students will be the same. Let me repeat. For both men and women, so we have 200 men, we have 100 women, the proportion of between domestic students and international students will be the same. That is, if we only look at the male group, there will be, 4 domestic students or 4 domestic male students for every 5 male students. And this proportion should be the same for men and for women, right? So in other words, at this second step, this is our first step, right? Stratify by gender. At the second step, where we stratify by student being domestic and international, our sample size is no longer 300, but 200. Okay, so and if we can, make sense of this step, right? That is, now we should stratify men based on their being domestic or being international. Then the second step will be very easy, right? Because for every 5 men, there will be 4 domestic students. So we simply time this by 200. And that's very easy to calculate. We should have 160 male domestic students. Okay? 160. Similarly, right, we can figure out how many male international students there should be. Right? So the first step is still this, right? To figure out how many men we need, 200. Well, then for these 200 men, how many international students there should be? Will be 200 times, what is it? For every 5 men, there will be 1 male international students. That's 40. Okay? And then you can similarly work out how many female domestic students, how many male international students, and how many female international students. Okay? By repeating the procedure. So we just said that here is 40. Okay? How about women? Women is easy, right? So we just said, because men and women, the proportion is 2 to 1. So that means if we want 300 people, we'll first of all need this much women. Okay, so this is the number of women we need. Now, for the next step, we'll be treating this number, whatever number it is, right, as the sample size. And now we reason, well, for this many women, there will be 4 international students, 4 domestic students for every 5 people. Okay? So we can solve this, problem very easily. So 300 times 1/3, that's exactly 100, times 4/5, that's 80. So we should have, 80, right? 80 female domestic students. How many male international? We just worked this out. 40. Okay? How many female international students? Very easy. We first work out how many female or women we need. Now work out how many international students we need. This is 1, right? Because for every 1, for every 5 people, 4 plus 1, there will be 1 international student. So this is 100 times 1/5, 20. Okay? We can quickly verify this. 160 plus 80, that gives us 240. 40 plus 20, that gives us 60. Fantastic. We add these two up, that will give us 300. So we satisfy the first criteria, right? We need 300 people. Now, do we keep the proportion of men and women correct? We should, because now we'll have exactly 200 men and we have exactly 100 women. 200 versus 100, that's 2 to 1. We have exactly 240 domestic students and 60 international students. So 240 divided by 60, that's exactly 4, right? 4. For every one international students, we have 4 domestic students. So everything works out. Okay, so make sure you understand this example, right? And then I will give you a further question here. Okay, there actually is no further questions, but make sure you understand this, and that will be very critical for you to work out the homework assignment. Okay, because I believe there's very similar, questions on the homework assignment that will need you to work out the number of people that one should include in a sample based on multiple stratifications. Okay? All right. Cool, huh? And interesting. Okay, now let's look at another example, which is not really stratified sampling. So let's imagine there's this country named Asirama in the world, okay? And it has a population of 321 million people, okay? And this country is divided up in a very interesting way. It has exactly 50 states. Sound familiar, huh? And these 50 states are very much like each other. We call it very homogeneous. Okay, homogeneous being very similar, have very similar gender composition, as in all states has similar compositions of, political parties, have similar levels of education, blah blah blah. Well, there will be differences, of course, across the states, but they're largely similar. Okay, so here's the qualifier here. Okay, so your goal is to analyze the personal income of this country. And we just said, if you want to analyze the personal income of a country, the unit of study will be individuals, right? You need to survey every single person in this country about, the person's income level, okay? But then, of course, you don't have that much resources to perform a study that includes everybody in this country because there are 321 million of them. You have simply no possibility of surveying every and each of them. Okay, so you decide to draw a representative sample of, as Raminians or as the Ramins. Okay, how would you proceed? How would you proceed to draw a representative sample of people from this particular country? Okay, pay attention to the feature of this country, that it has 50 states that are more or less like each other. Aha, that sort of gives us a hint. That means if the country, or if the population of 321 million people are divided into 50 states that are largely similar to each other. That means we don't have to survey every single individual from every single state. We can probably first of all decide, or randomly decide more precisely, to survey a subset of the 50 states because, well, they're largely homogeneous, meaning your survey study, state one is very like, will be very much like the result of surveying state number two. And the result from surveying state number two will be very similar to surveying the state number 50 because, well, they're more or less like each other. There will be differences, but not huge or vast differences. Okay? If you are thinking this way, then congratulations, you are thinking the correct way. So, more precisely, there are these steps we could follow. And we call this particular method of sampling multi-stage cluster sampling. Stage 1, or step 1 in this case, is to randomly sample a subset of the 50 states. And then from the selected states, you randomly sample a subset of counties, assuming that counties in any particular state are also largely homogeneous. And from the selected counties, you sample a subset of cities, assuming that the cities are also largely homogeneous across each county. And do the same thing for blocks, do the same thing for households, and very lastly, you randomly sample an individual from the selected households. So the advantage of doing this, or the advantage of performing multi-stage cluster sampling, as you can see, you by randomly select all these subunits that constitute the entire country, you effectively reduce the amount of work that you should do. Because, for example, right, let's say out of the 50 states, you randomly select 25 of them. And from the 25 states, you select, perhaps for each selected state, you select, let's say, 10 counties. And for each 10 for the 10 counties in each state, you select 5 cities. And from the 5 cities that you select from each country, you select 3 blocks. And from the 3 blocks that you select from each city, you survey 10 households, right? And you select from the 10 households from each block 1 individual, right? So in the end, you're doing, how many people? So you're going to survey, from every single individual from 1 household, and that's from 3 blocks, and that's from 5 cities, and that's from, 10 counties, and that's from 25 states. So how many people are you surveying? So 30, that's 300, that's 1,500, 1,500 times 22, what is it? So 7,500, 30. You're only surveying 37,500 people compared to 321 million individuals. That's a huge reduction in the amount of work that you will need to do. But because you do randomly sample all the time, and because all these subunits, states, counties within states, cities within counties, blocks within cities, households within blocks, all these subunits, under the previous upper level units, share a certain degree or sufficient degree of similarity, you will still be able, if we follow random sampling closely, you will still be able to obtain a largely representative sample of the population. So that's the beauty of performing multi-stage cluster sampling. right? And multi-stage cluster sampling is usually performed on geographic units, states, counties, cities, blocks, households. And by doing that, you see, you're not serving everybody, but still, the results that you apply, that you are able to obtain from surveying these many people should be, right, generalizable to the entire population, provided that you follow these steps closely or as closely as possible. Okay? So this is the idea of multi-stage cluster sampling, right? So the core idea, as we just illustrated, is to break the population into smaller, but you know, smaller units that are as similar as possible, right? That would be ideal, right? But of course, in real life, that's not never going to happen, right? We know that the state of Maine is very different from, it's kind of different from the state of California, right? You know, but still they're Americans. We can still have a certain amount of Republicans and Democrats and things like that, right? So it is possible that they share a certain degree of similarities. Okay, and of course, from each of the units, you obtain a random sample of the units, and you proceed with that, right? So then, for a thought exercise for you, then imagine you would like to study the quality of primary education in U.S. How would you plan your sampling, right? So, for example, given this is your goal, right, is to study the quality of primary education in the U.S., you might think, well, perhaps, the unit of study here will be, primary schools, right? How good the primary school will be, right? So then you can say, well, let's first of all, select a subset of states in the United States, maybe 30 out of 50, right? Then from each of the state, you select certain counties. From the selected counties, you selected certain cities. From certain cities, you selected a certain number of primary schools, right? And then you go to evaluate or assess the quality of those primary schools in terms of student performance, etc. Okay, that will be one sampling plan based on multi-stage cluster sampling. So now we have two um, very useful types of sampling plan. The first is stratified sampling. Okay, so the core idea of stratified sampling is to divide populations into smaller units. But very importantly, the units that we divide the sample population into are very different. And they're usually non-overlapping, right? It's men versus women. In contrast, for cluster sampling, you also divide populations into smaller units, but the units that you are dividing the population into are ideally comparable, right? As comparable as possible, right? United States or provinces in China or provinces in Canada, etc. So you see, for both sampling methods, you're dividing the population into smaller and manageable units, but the nature or the content of the units are very different. Here you want very different units. Here you want very similar units. Okay? All right. So we'll end our third lecture here, right? So in this particular lecture, we introduced two important sampling techniques: stratified sampling and multi-stage cluster sampling. So the idea is that to obtain strata that could help us correct for the under or over representation problems, and cluster sampling is to help us to conduct surveys more efficiently, right? Especially when we encounter a goal that involves surveying a huge amount of individuals. Okay, so both sampling methods are very useful and they're used in different contexts and for different purposes. Okay, so that concludes our lectures on surveys, and tomorrow we'll be talking about experiments, and at the same time we have our first assignment due by midnight tomorrow. Okay, that is before it turns the 21st. Okay, so as usual, let me know if you have any questions, and I will see you tomorrow.